Okay, let's consider another example on inhomogeneous where f of x is an exponential. I said we'll be looking at 3 examples on this, so this is the second example. Okay, now let's go straight to the point. We know our general solution is y is equal to yc plus yp. Okay, so my differential equation, my auxiliary equation will be 2m square minus 2m square minus m minus 3 is equal to 0, and the d operator should be 2d square minus d minus 3y equals to 5 exponential 3 over 2x. Okay, now if we are to solve this quadratic equation, we end up having my m to be 3 over 2 and m to be minus 1. Therefore, my yc is equal to a exponential 3 over 2x plus b exponential minus x. That's my yc. Now it remains my yp. Since f of x, let me write it here. Since f of x is equal to 5 exponential 3 over 2x, then yp will be a exponential 3 over 2x. That's the way it should be. But I realize that my m is 3 over 2 and this b here is 3 over 2. Since m is equal to b, then this is not correct. You will now be using ax exponential 3 over 2x, which I explained in the definition earlier. Therefore, yp is equal to ax exponential 3 over 2x. Now, putting that into the operator, that's the same thing as 2d square minus d minus 3 into bracket ax exponential 3 over 2x is equal to 5 exponential 3 over 2x. Okay, now it means if we are to open this bracket, it means this 3 will multiply this d, meaning we are differentiating what is there once, and this means we are differentiating what is there twice. So to make life very easy, I can break it down by saying, let's take it one after the other. Minus 3 of what is there, ax exponential 3 over 2x. That's by opening the bracket, that's minus 3a exponential, minus 3ax exponential 3 over 2x. That's for the first one. Now, minus d ax exponential 3 over 2x. It means I want to differentiate what is here once. After differentiating it, then I multiply it with minus sign. Now, to differentiate what is here, this is a function, this is a function, product true. So I can say it's the same thing as this minus that is outside. It will multiply my final answer. So let me write the minus with a red pen into bracket, multiplying the final answer, which is the derivative of what is there. Now, if I want to differentiate what is there using product rule, that's u differentiate this times 3 over 2 exponential 3 over 2x plus a exponential 3 over 2x. So at this point, I've differentiated first derivative, which I can say that is equal to, the minus outside. Let's factorize a out. That's a exponential 3 over 2x into bracket 3 over 2x plus 1. Okay, or better still, to make life very easy, I can remove this minus, I can remove this minus. So I know that for my expression is only d of this. That is d. I only differentiated this. Then later we'll attach our minus to it. So that's what first derivative. Okay, but we have d square, which is second derivative. So let's do that one here. D square into bracket ax exponential 3 over 2x. It means we are differentiating this twice. Thank God we've differentiated once here, which is the same thing as this. So if I differentiate this, it should give me this, the second derivative of this. So now let's differentiate this using product rule. What is here is, using product rule, what is here is u, what is here is what? V. So applying product rule to that will give us a exponential 3 over 2x. Let's differentiate what is in the bracket. That's 3 over 2 plus, write your this 3 over 2x plus 1. Now let's differentiate this. That's 3 over 2a exponential 3 over 2x. Okay, now can we factorize? What can we factorize out? We can factorize a exponential 3 over 2x out. We can factorize that out. Then we say we have, when we factorize this out, you are left with 3 over 2 plus so let's factorize that. I have this 3 over 2 to be this. I have this times this, that's 3 over 9 over 4x plus 3 over 2. 9 over 4x plus 3 over 2. Close the bracket, which is the same thing as a exponential 3 over 2x into bracket 9 over 4x plus 3 when you find the LCM. Okay, now this is the second derivative. Let me note that with an asterisk. This is the second derivative. Okay, this is our first derivative, and this is the constant part. And then this is what we are looking at. This is what leads to those parts. This. So let's write this out. So writing that out, I have it to be that's 2d squared minus d minus 3 into bracket ax exponential 3 over 2x, which is equal to 5 exponential 3 over 2x. Okay, now 2d squared, this is d squared. Now multiply it with 2. That will give us 2 into bracket a exponential 3 over 2x into bracket 9 over 4x plus 3. Close the bracket, close the bracket. That's for this part. Minus d. This is d here. So I'll just attach minus to it. That's minus into bracket a exponential 3 over 2x into 3 over 2x plus 1. Close the bracket. Minus 3 of this, that's when we multiply minus 3 with this. That's minus 3ax exponential 3 over 2x. Then everything is equal to 5 exponential 3 over 2x. Okay, now let's simplify. Let's factorize. Let's do everything we can do there. Then we can say that, okay, what is there is the same thing as, this 2 is multiplying what is there. So if I multiply it with the 2, it's going to give me 9 over 2x plus 6. 2 times this, 9 over 2. 2 times 3 is 6. Then I have it to be like this. Sorry, that's a mistake. Okay. A exponential 3 over 2x. That's for the first one. Minus into bracket 3 over 2x plus 1. A exponential 3 over 2x minus 3ax exponential 3 over 2x is equal to 5 exponential 3 over 2x. From this left hand side here, everything that is here, exponential 3 over 2 is common, exponential 3 over 2 is common, exponential 3 over 2 is common. I can factorize it out. So factorizing this exponential 3 over 2 will cancel the exponential 3 over 2 here. Therefore, this exponential 3 over 2 cancel after factorizing this out. It cancelled each other. Then since I've factorized this out, and it have cancelled each other, I'll be left with a and this. That's 9 over 2xa plus 6a. Here I'll be having a times what is there, which is minus 3 over 2xa minus a, and then minus 3ax is equal to, we are left with constant here, 5. Now let's form our quadratic equation. Since there's no x at this part, it is only constant, then it means x is 0 at this part. Shall you get? So all the one that is having x is out of it, is out of it, is out of it. So the constant and constant, that's 6a minus a is equal to 5. 5a is equal to 5. Therefore a is equal to 1. Since a is equal to 1, we all know that my yp initially is ax exponential 3 over 2x. But what is a? 1, which is the same thing as exponential x exponential 3 over 2x. So the yp that we've been looking for is the same thing as this. Now I can now say that my general solution is what? Y is equal to yc plus yp, which is the same thing as y is equal to, what is yc? Let's go and check our yc. Let's go and check our yc. Okay, this is our yc here. So yc is what? A exponential 3 over 2x plus b exponential minus x. So that's a exponential 3 over 2x plus b exponential minus x. That's for yc. Now plus yp. What is our yp? X exponential 3 over 2x. Final answer. Okay, so that's how we solve that type of question. But don't forget, under exponential is either it should be ordinary a exponential bx when m is not equal to b, but this one is when m is equal to b, and we'll be considering another example where m is equal to b, but m occur twice, 3 times, k times. Sure, you get what I'm trying to say? So in our next video, we'll be looking at the third case. Thank you.